Live from an obscene area somewhere in Northern California, this is Miss Miller's Math Show, with your host, an engineer technician turned public servant from an education, from Cuckoo, California, Miss Miller, and the co-host, a public servant for education assistant from Slumpdon, Nebraska, Crystal. Now here's your host, Mrs. Miller.
Nicely done. Okay, here we go. So I have to warn you all. You know that feeling you get when you're about to get sick? Where like your throat starts to get sore and your nose okay, so that's where I am right now. So we're going to try and keep these notes as short and sweet as possible. Okay? Okay, that I have to repeat that. So these notes don't look short or sweet; they look angry and sad. That is too bad. Yeah.
Is that an addition sign or a division
sign? That's addition and that's subtraction. Okay, everybody, stop talking. Yes, it says complex rational expression. So let's talk about what that is. A complex rational expression is a fraction within a fraction within a fraction within a fraction. It's like every math student's dream problem, right?
I actually like that. She's got jokes.
In case you haven't noticed, I'm a little bit sarcastic. Okay, Alyssa, you had your hand up.
I think
Okay, we'll talk. Okay, Mrs. Miller. And can I send him in a little bit? All right, here we go. Okay, you guys have to remind me that somebody needs to go to the office after notes, okay? So just remind me of that. Okay, here we go. So let's break this down piece by piece. Shh. Let's start with the top, okay? We spent a lot of time yesterday doing this type of problem. So this type of problem being adding and subtracting rational expressions with unlike denominators. So how many people would agree that y is the same thing as y over 1? Is that true?
Yes.
Cool. So by writing it as y over 1, I did not change the problem. So would you all agree that those two things are equal to one another? Okay? Now, if we wanted to add y over 1 to 1 over 2, what do we have to do to one or both of the fractions so that we can combine them into one giant fraction? Olivia?
You have to multiply y over 1 by 2 over 2 so that way it has the same denominator as 1 over 2.
Excellent. Everybody give it up for Olivia.
Yay.
Can you guys see that light color? Okay?
Yeah.
All right. Okay. Now, so the bottom is very similar. Y is the same thing as y over 1 again, minus 1/7. So now we want to do something very similar to this bottom. This huge, huge denominator that we have going here. In fact, what I want you guys to do is get some parentheses going here so that you can keep everything straight, okay? All right, so anybody have any suggestions about what we might want to do here? Aiden. Good. Multiply it by 7. Everybody give it up for Aiden. Okay. So, on the top, when we multiply, we get y times 2 is 2y over 2 plus 1/2. Again, keep your parentheses here. And then on the bottom, we have 7y over 7 minus 1/7. Okay, so now that we have the same denominator, anybody remember what we do next? Okay, somebody other than Aiden. Aiden's box is full. He's full. Shuggy.
I just had a question.
Go ahead.
I was thinking that you can do 2y plus 1 so it would be 3y, but can you not do that because there's no y?
Exactly. They're not like terms. But what we can do is combine them into one fraction like this. So it's 2y plus 1 over 2. 7y minus 1 over 7. Perfect. Everybody give it up for Shuggy. Now, here's a side note. How many people can tell me if I put, let's see, 14 over 2. 14 over 2 is equal to what? 7. Why is it 7? Okay, because 14 divided by 2 is 7. So we all can agree that a fraction line means the same thing as division, correct? Okay. Anybody remember how we divide fractions? Same, change, flip. Perfect. Give it up for yourselves. Ourselves. Okay. So the top stays the same. We're going to change the middle fraction line to a multiplication, and we are going to flip the bottom. Okay, so when we keep the top one the same, the top one stays as 2y plus 1 over 2. We change the division to multiplication and then flip the bottom one. So times 7 over 7y minus 1. All right, now is where we're back to something that we have been spending a lot of time doing, and what we want to do is see if there is anything that can be factored or reduced in any way, shape, or form. People are going like this. No, no. True. Good. So what do we do? What do we do when we can't factor anything? Sloan? Aiden? Cool. Everybody give it up for Aiden. So all Aiden did was smash them together. Smash, smash, smash. Okay, I'm really tired.
It's Friday, we're all trained.
Well, when you have a child at home.
Ooh, not you.
Oh, from you. Okay, that's true. I don't know where that tiredness comes from either. Okay. All right. Questions on this one? Okay. Oh, yes. Nope. Do not distribute. You can if you want to, but I mean, I know all of you really want to distribute because you just love math so much that you can't help yourselves. So if you are in that category, go right ahead. I'm not going to stop you. But you can leave it like this as well. Okay, here we go. Next one. Oh, all right. Let's just put this up here. Shh. All right. Notice in this problem, so this is our new problem over here. Here's what I want you all to notice. This one actually looks more horrendous than the last problem, but it's actually easier because in the last problem, we started out with two completely separate fractions on the top and two completely separate fractions on the bottom, and we had to get them into one giant fraction on the top and one giant fraction on the bottom so that we could do same, change, flip. But in this one, we already have one giant fraction on the top and we already have one giant fraction on the bottom, which means we can go straight to what? Same, change, flip. Everybody give it up for Shuggy.
Yay, Shuggy.
Say, that was so awful. Everybody give it up for Shuggy.
Yay, Shuggy.
Okay. So we keep the top as c squared minus 1 over 4c plus 4. We change division to multiplication, and then we flip the bottom to be c plus 1 over c minus 1. So last period told me it is way too cold in here, so I turned it up a couple degrees. That was a mistake. It's now like a sauna in this
Now I'm
classroom.
like thrown off because of the sound. Go back to the
No, it's actually quiet. It's quiet.
Yeah, I know, but it's like, now it's just empty.
Now it's just empty. What do you mean it's empty? They're all of you here.
I know, but it's like empty without like
The background noise?
Concentrate and sneeze.
So now we want to look for anything that can be factored. Samantha. Excellent. Everybody give it up for Samantha.
Yay.
So c squared minus 1, does anybody remember the actual, there's like a technical name for that. Alyssa?
Difference of 2 squares.
Excellent. Give it up for Alyssa. Difference of 2 squares.
Yay.
Okay. Now, anything else that can be factored? Sloan.
4 can be factored.
Good. And when you factor it out, you get what?
C plus 1.
Cool. Everybody give it up for Sloan.
Yeah.
Okay.
Yay.
Now, I'm going to just rewrite this so that organization is a huge, huge, huge thing in these problems. So I'm going to rewrite this so that we can keep everything straight that we have left. C minus 1. Now's where the fun part starts. We get to cancel stuff. Zach.
Cut out C minus 1 on both sides.
Good. Cut out C minus 1. Everybody give it up for Zach.
Yay.
Right. What else? Liz. C plus 1. Does it matter which one? Can I do this one with this one or this one with this one? Doesn't matter. Okay. Everybody give it up for Liz. Okay. Anything else? So what's my final answer? Aiden? No. Alan.
C plus 1 over 4.
C plus 1 over 4. Everybody give it up for Alan.
Yeah.
All right. Questions? We are done.
That's it?
That's it. And I am in a very big extra credit mood right now. So your homework is due in, you guys still have a really, really long time until the end of the period. So the homework is due at the end of the period, but it's either you get the extra credit or you get nothing. Meaning you have to show your work. As long as you show your work, you get extra credit, and it is due at the end of the period. All right? Everybody say